In the cold, freezing vastness of space, a truly chilling reality exists. Millions of invisible entities with infinite weight are silently drifting around us without emitting a single ray of light. According to official reports from the Laser Interferometer Gravitational Wave Observatory, these unseen objects possess an overwhelming gravity that literally crushes light itself. Humanity has long believed that black holes are only born from the violent death of massive stars. However, modern astrophysics now reveals a much darker, more terrifying truth. Some of these silent monsters actually existed long before the very first light of the universe ever appeared. What they saw next would change everything we thought we knew. To truly comprehend the birth of these dark entities, we must first witness the violent death of a giant. In the vast field of astronomy, the formation of a stellar mass black hole stands as one of the most violent events ever recorded. For millions of years, a massive star survives through a delicate, relentless battle. Deep inside its glowing core, nuclear fusion burns at temperatures of tens of millions of degrees, creating an immense outward pressure. This outward thermal force perfectly counters the crushing, inward pull of the star's own monumental gravity. It is a brilliant, fiery equilibrium that lights up the dark void. However, this stellar balance cannot last forever. As the giant star exhausts its primary hydrogen fuel, it begins desperately fusing heavier and heavier elements to survive. Hydrogen turns into helium. Helium fuses into carbon, oxygen, and silicon. This cycle continues relentlessly until the core finally fuses into iron. Iron is the ultimate fatal dead end for nuclear fusion. Fusing iron atoms absorbs energy rather than releasing it. In that exact moment, the outward pressure drops to zero. With nothing left to push back against the weight of the outer layers, the fundamental laws of astrophysics take over. Gravity, the most persistent and unforgiving force in the universe, finally wins the million-year war. In a fraction of a single second, the entire weight of the massive star comes crashing down. The iron core collapses inward at nearly the speed of light. Trillions upon trillions of tons of superheated matter slam into the absolute center, creating a catastrophic shockwave that violently rips back outward through the outer layers. The star detonates in a blinding supernova, an apocalyptic explosion releasing more energy in a single moment than our sun will produce in its entire lifetime. Yet, the most terrifying event happens beneath the explosion. The crushed core does not stop collapsing. The crushing gravitational weight completely overcomes all known physical forces, packing a mass several times greater than our sun into an infinitely small, infinitely dense point. To have this science explained simply, the physical matter is crushed completely out of existence as we know it, forming a singularity. The gravitational pull surrounding this singularity becomes so extreme that the very fabric of space and time completely warps. A boundary forms around the dead core, a point of no return known as the event horizon, where the escape velocity exceeds the speed of light. The star is gone, and a black hole remains. This mechanism is not merely a theoretical concept. In the year 1964, researchers detected a massive, inexplicable source of high-energy radiation pouring from a distant constellation. They named it Cygnus X1, and it would eventually become the very first confirmed black hole in human history. Cygnus X1 is a dark monster, roughly 15 times heavier than our sun, located over 6,000 light-years away. Yet it remains completely invisible to the human eye. We only know it exists because of the brutal, chaotic way it feeds. Cygnus X1 is locked in a deadly orbital dance with a massive blue supergiant star. The black hole's extreme gravity constantly rips stellar material directly off the surface of its glowing companion. This stolen, superheated gas spirals inward, forming a massive accretion disk. As the material races around the black hole at nearly half the speed of light, intense friction heats the gas to millions of degrees, blasting out the brilliant radiation that our instruments detect from Earth. It is a slow, cosmic execution, an endless feast of destruction. But while the explosive death of a massive star represents one terrifying origin, the cosmos harbors a much older, darker secret. To comprehend the true origin of these dark anomalies, we must travel backwards through time, far beyond the lifespan of the oldest stars. We must return to the very beginning, exactly 13.8 billion years ago, during the fiery birth of existence known as the Big Bang. A common misconception dictates that a massive star is an absolute requirement to forge a black hole. However, the vast field of cosmology completely shatters this assumption. Long before the first atomic bonds formed, long before the first primitive stars ignited, the early universe was an infinitely hot, extraordinarily dense ocean of raw energy. It was an environment of absolute, unrelenting chaos. During the first fractions of a single second after the initial expansion, this cosmic soup was not perfectly smooth. The fundamental rules of quantum physics state that microscopic variations must exist at the subatomic level. These tiny energy variations are known as quantum fluctuations. In the extreme pressure of the newborn cosmos, these microscopic fluctuations created localized regions where matter and energy became overwhelmingly concentrated. These specific regions were so incredibly dense that they did not need a dying star to trigger a gravitational implosion. The sheer density alone forced the immediate fabric of space-time to collapse directly upon itself. This instantaneous, violent phenomenon gave birth to a completely different breed of cosmic entities, primordial black holes. Because they were forged in the high-pressure environment of the early expansion rather than from stellar death, primordial black holes are not bound by the standard mass limits of stellar remnants. This physical reality leads to one of the most astonishing truths to have the universe explained simply. These ancient cosmic traps can be almost incomprehensibly small. Theoretical physics reveals that a primordial black hole drifting through the void today could contain the entire mass of Mount Everest, effectively carrying billions of tons of physical weight. Yet, all of that monumental mass would be violently compressed down into a physical dimension no larger than a single microscopic proton or a tiny grain of sand. What would you feel if you saw this with your own eyes? Drop your thoughts in the comments. These microscopic phantoms have been silently traveling through the dark voids for almost 14 billion years. Because they are extremely small and emit absolutely zero light, they remain completely invisible to our most advanced optical instruments. Some researchers theorize that swarms of these ancient relics might even be passing through our own solar system right now. If a primordial black hole with the mass of a mountain were to strike our planet, its microscopic size and extreme velocity would allow it to pass entirely through the Earth in a fraction of a second, leaving behind only a highly localized, untraceable wave of seismic energy. Their existence fundamentally challenges our understanding of gravity. Furthermore, studying these early temporal anomalies provides critical data that physicists use to explore the mathematical possibility of a highly complex multiverse where different expanding realities might produce infinite variations of these dark remnants. By searching for these ancient entities, we are essentially looking for the foundational fingerprints of creation. They represent the darkest, oldest echoes of the Big Bang itself. Understanding these ancient relics reshapes our models of creation, yet to truly grasp their modern terror, we must observe how they feed. While primordial anomalies drift silently through the void, the true terror of a black hole is fully revealed when it feeds. The cosmos is not a peaceful sanctuary. It is an environment of brutal consumption. For decades, astronomical observation has shown us that black holes grow by pulling in surrounding gas and dust, forming a glowing accretion disk. However, the most violent and unsettling method of growth occurs during a phenomenon known as a tidal disruption event. In the dense centers of many galaxies, stars orbit in chaotic, crowded paths. Occasionally, a wandering star strays too close to the dark boundary of a massive black hole. When this occurs, the fundamental laws of science dictate a horrific and inescapable conclusion. As the star approaches the event horizon, the gravitational pull acting upon it is no longer uniform. The leading edge of the star, the side physically closest to the black hole, experiences a drastically stronger gravitational force than the trailing edge located just a short distance further away. This extreme difference in gravity creates a tidal force so overwhelmingly powerful that the star itself begins to deform. The internal structural integrity of the star, normally held together by its own immense gravity, completely fails. What follows is a brutal physical process technically referred to in astrophysics as spaghettification. Under this relentless and unforgiving gravitational stress, the star is stretched vertically and severely compressed horizontally. The intense pressure literally rips the star apart at the basic atomic level. It instantly ceases to exist as a glowing sphere and is violently transformed into a continuous, blistering stream of superheated gas. This river of stellar plasma, rapidly heated to millions of degrees, stretches across millions of miles of empty space. As the star is flayed layer by layer, roughly half of the destroyed material is violently flung outward into the deep void. The remaining material spirals rapidly downward into the black hole, wrapping around it to feed the dark core. As this material accelerates to nearly the speed of light, it creates an intense, blinding burst of high-energy radiation. We do not have to rely on mathematical theory to verify this devastation. The Chandra X-ray Observatory, a highly advanced satellite operated by the National Space Agency, has continuously captured the exact moments these high-energy bursts illuminate the dark universe. The official telemetry from Chandra reveals that these feeding frenzies are not quick. They can last for several years, emitting continuous, blinding radiation as the black hole slowly and methodically devours its stellar prey piece by piece. This process stands as a chilling reminder of the absolute ruthlessness of nature. If such a catastrophic event were to somehow occur near our own solar system, the resulting destruction would be absolute. Every planet, every moon, and the sun itself would be stretched into a thin ribbon of atomic dust, pulled down into the dark abyss without leaving a single trace. It is a cosmic execution that leaves absolutely no survivors. Any comprehensive space documentary attempting to explain the universe must acknowledge this terrifying reality. Black holes are not simply static gravitational wells. They are active, feeding predators that shape the structure of the cosmos through sheer, unyielding destruction. Observing this distant destruction forces a chilling question upon humanity. How close is the next cosmic execution to our own world? A widespread and fundamental misconception often plagues the public understanding of stellar physics. Many believe that our own planet, or the gas giants within our solar system, could one day collapse into a dark singularity. This is physically impossible. A planet simply does not possess the immense gravitational weight required to crush atomic structures into a point of infinite density. To witness the birth of a new black hole, we must look far beyond our local neighborhood, deep into the Milky Way galaxy, and fix our gaze upon dying massive stars. The true candidates for the next cosmic execution reside hundreds, or sometimes thousands, of light-years away from our solar system. In the expanding field of space exploration, two of the most heavily monitored targets are the highly unstable massive stars known as Eta Carinae and Betelgeuse. Eta Carinae is a volatile binary stellar system located thousands of light-years away, possessing a combined mass roughly 100 times greater than our Sun. However, the most immediate and looming threat, the ticking time bomb sitting practically in our own cosmic backyard, is the red supergiant star Betelgeuse, located prominently within the Orion constellation. Betelgeuse is positioned approximately 640 light-years from Earth. It is a dying, pulsating giant. Its outer atmosphere has swelled to such an enormous size that if it were placed in the dead center of our solar system, its fiery surface would completely consume the orbits of Mercury, Venus, Earth, and Mars, reaching nearly all the way to Jupiter. Recently, this monstrous star exhibited deeply unsettling behavior. Starting in late 2019, global astronomical networks and the Hubble Space Telescope, a primary instrument operated by NASA, recorded a massive sudden dimming event. The star's visual brightness dropped to an unprecedented low. Data analysis eventually revealed that Betelgeuse had violently ejected an enormous cloud of superheated plasma. As this expelled material cooled in the freezing void, it formed a massive dust cloud that temporarily blocked the starlight from reaching Earth. While this specific event was not the final explosion, it serves as a stark, undeniable warning that Betelgeuse is rapidly nearing the absolute end of its life cycle. Inside its core, a frantic and desperate nuclear fusion process is racing toward its inevitable conclusion. When the core finally fuses into solid iron, the internal thermal pressure will instantly fail. The core will collapse in a fraction of a second, and Betelgeuse will detonate in a spectacular supernova. The sheer violence of this explosion will instantly obliterate the star's outer layers, leaving behind a brand new stellar mass black hole. When the light of this apocalyptic detonation finally reaches Earth, the visual display will be nothing short of terrifying and magnificent. Any high-quality science documentary attempting to predict this event notes that the dying star will shine with the intensity of a full moon. It will cast distinct shadows on the ground at night and remain clearly visible in the bright blue sky during the day for several weeks before slowly fading into total darkness forever. For humanity, this event will be an unparalleled scientific spectacle. At a distance of over 600 light-years, our biosphere is completely safe from the lethal burst of high-energy radiation. However, the exact same cannot be said for the immediate cosmic neighborhood surrounding the star. Any planets orbiting within a radius of 50 light-years of Betelgeuse would face absolute biological sterilization. If any form of alien life exists within that critical blast zone, its atmosphere would be violently stripped away, and its surface scorched by relentless gamma rays. The birth of this new black hole requires an act of supreme cosmic violence, purging its surrounding space of all complex molecular structures. As we monitor these fading giants, the realization dawns that the timeline of stellar collapse is vastly different from our human clocks. When we observe a distant celestial body like Betelgeuse, we are not seeing the star as it exists in this exact moment. Because this unstable red supergiant is located approximately 640 light-years away from our planet, the light it emits takes over 6 centuries to physically cross the cold interstellar void. This creates a profound temporal paradox. If Betelgeuse were to undergo a catastrophic supernova collapse today, humanity would not witness the fiery explosion for another 640 years. Conversely, it is physically possible that this massive star already died during our own earthly Middle Ages. The brilliant, blinding light of its final destruction could be rushing through the vacuum of space at this very second, preparing to finally strike our skies and illuminate our daytime atmosphere tomorrow morning. For centuries, our entire understanding of the cosmos relied strictly on capturing various spectrums of light. However, humanity has evolved beyond our biological limits. We are no longer restricted to merely looking at the stars. We are now actively listening to the dark void. In recent years, astrophysics achieved a monumental breakthrough with the Laser Interferometer Gravitational Wave Observatory, commonly referred to as LIGO. This highly sensitive facility operates unlike any traditional optical telescope ever constructed by man. Instead of gathering ancient light, it is engineered to precisely measure microscopic ripples passing through the very fabric of space and time. When two massive black holes collide and merge billions of light-years away, the event is completely shrouded in darkness. They do not emit a single visible spark. Instead, they unleash a violent, apocalyptic storm of gravitational energy that physically distorts reality itself. LIGO successfully captured the physical echoes of these ancient invisible collisions, essentially translating the sheer unseen violence of the cosmos into a measurable, audible frequency. This extraordinary technological achievement verified fundamental concepts of space theory, confirming that space itself can stretch, compress, and ring like a struck bell. We successfully recorded the final roar of dead titans from across the universe. This monumental transition from sight to sound marks a beautiful evolution in human capability. Yet, our physical reach into the dark is also expanding at an unprecedented rate. To ensure we do not miss the next great cosmic event, modern aerospace engineering is aggressively pushing our observational boundaries. Advanced organizations, driven heavily by the revolutionary reusable rocket technology developed by SpaceX, are consistently launching intricate networks of autonomous satellites and deploying next-generation space telescopes into high orbit. These sophisticated research stations are strategically placed far above the thick, distorting layers of our own atmosphere, permanently extending the eyes and ears of humanity deeper into the absolute unknown. By systematically building a vast, interconnected sensory web across the local void, we are eagerly preparing to capture the breathtaking new discoveries that remain hidden in the pitch-black silence. Every new launch represents a beacon of human hope, an enduring aspiration to understand our precise place within this magnificent architecture. Let me know below what struck you the most about our profound ability to listen to the very fabric of the cosmos. Ultimately, these dark entities are not the meaningless cosmic garbage dumps they were once thought to be. They are extraordinary, natural time machines, representing the absolute final frontier of modern physics. Through their extreme gravitational pull, they trap the ancient history of creation and continuously test the very limits of our scientific knowledge. It is profoundly inspiring to realize that humanity, a fragile species possessing a biological lifespan of less than one single century, holds the immense intellect required to completely decode the violent collapse of a massive star that burned brightly for billions of years. We might be vanishingly small when compared to these dark behemoths, yet our unique capacity to observe, listen, and understand their complex mechanics proves that we are fundamentally connected to the vastness of space. The universe isn't broken. Our map of it is just incomplete. What do you think? Does this change how you see our place in the cosmos? Thank you so very much for watching. The universe is full of terrifying yet beautiful mysteries, and exploring them together makes this journey incredible. If you enjoyed this deep dive into the dark cosmos, please subscribe and leave a comment below. I will keep exploring. See you all next time.